So let us treat the last aspect of condenser, which is capacitor. So the energy stored in capacitor. So we can say that what the energy stored in capacitor, the energy stored in capacitor is equal to the work done in charging the capacitor. And the graph of Q against V, which is potential difference, is straight line that passes through the origin. And the area under this charge is the work done in moving the what? The charge or energy stored in capacitor. So here now, in the graph, you can have the graph to be in this form. Graph of what? This is the axis of the graph. Call it what? Graph of Q in column against what? Potential difference in what? In V. And the graph is a what? A straight what? A straight line curve. So if you draw the graph, it's a what? A straight line curve. So if the graph is what? It's a straight line curve. So they say the graph is this is straight line. The area under the graph is the work what? Done. So let us look at the what? The area under the what? The graph. If we look at the area under the graph, we will look at the what? This shaded segment here in the graph. The shaded segment in the graph, it will be the area of the what? Of the graph. And this region, this shaded segment of the graph, you can also call it what? Work what? The work. This is the area of the graph. Area of the what? graph, which is also equal to the what? Work done of the what? Of the graph. So from this graph, we can say that what? From the what? Let me write it here. From the graph above, we can say that energy this stored is equal to work done. Work done equal to the what? Area of the what? Of the graph. So if we agree that, so from knowledge of mathematics, let me say what? Therefore, area under the graph, under the what? Graph will be equal to what? Half times base. What is base? Potential difference. V multiplied by what? Height. What is height? Height is what? Is Q. Good. If area under the graph is this, we can later conclude that what? Our area will be equal to what? Half of what? What is this? V what? Q. So if note, and we also know that what? Area is equal to what? Energy what? Energy stored, which is E, or what? Work done. By doing that, we can have E equal to the what? Half of what? QV. We call it what? Equation what? Equation 1. By achieving this, we can now say what? Recall that Q is equal to what? CV. By substituting for this Q, what do we have? E equal to what? Half of Q is what? CV. V multiplied through, we have E should be half of what? CV square. This will be what? Equation what? Equation 2. This is the work done or energy stored in capacitor is this, or energy stored in capacitor is also what? This. We can also say similarly, see what? Similarly, from V equal to what? Q over what? Over C. By substituting for what? For E. For V here, you will now have E should be equal to the half of what? C Q over what? C. Everything what? Square. By solving this further, we have half of what? Half of C. Expand it. Half of C Q square over what? C square. This the cancel one C here. You will now have what? Half of what? Q square over what? Over C. This is also what? Another formula for what? For energy. We can now conclude that what we now conclude that the energy stored will be what? Uh, will be Q square over 2C. This is the third formula for calculating what? Energy stored in capacitor. So let us solve question on it. Take this question. Example 1. Calculate the work done in a capacitor. In a capacitor of 200 microfarads, where a potential difference PD of 1000 volts volts is applied. So let's solve this question. Solution. From this question, we are given capacitor to be 200 microfarad. We are given V as what? 1000 V. The next one is what? We are expected to find the work, calculate the work done, which is what? The energy what? Stored. So what formula relates CV together to the three formula? It's like we have second one, and say what? V equal to what? Half of CV square. We said using this equation what? Equation 2. By using that, we are going to end up with what? This is half, no? Can say what? Work done, for the what? Half multiplied by what? 200 times 10 raised to power minus 6 multiplied by, no? We have 100,000 square. By applying the calculator, at the end of the day, we will end up to the what? The work done will be 100 what? Joule. That's the work done. Let me ask one simple question to it again. Here, let's solve this question. 2. Capacitor has a capacitance of 10 microfarad. C is 10 microfarad. And charge on the plate is this. Our Q is what? What is the Q? 10 raised to power minus 5 coulomb. You are asked to find the what? Calculate the energy stored. The energy stored is what is this. What formula relates Q and C together? It's equation 1. So can I use what? E equal to the what? Half of Q V. E is 1 over 2. What is Q? Times 10 raised to power minus 5 times 10 raised to power what? 10 times 10 raised to power minus 6. This add minus 11. F is minus 11. This will be 5. Yes, 5. We have E should be 5 times 10 raised to power minus 11 joule. That's the final what? Answer. So the next thing is what? Let us look at energy density and the force on between the two plates.